move and see how this might work in the real world. All right, so here's a nice picture, and we're going to start with a concrete thing, and we're going to move towards an abstraction. Well, this is a picture that could be of any number of streets in any number of small communities anywhere in the United States or elsewhere in the world, perhaps. And we go, well, it's kind of boring, and I took it intentionally for it to look boring, because we have to start asking ourselves, well, why did you take the picture? What's important? And that's one of the questions that we ask in science. Well, what is important here? Well, maybe this is the first week of school and mom's just backed out of the driveway, and we're trying to figure out the best path, the best way to get our kiddos to school. Well, can we think of a better way to analyze it than just looking down the street and wondering whether to turn right or left or go the other way? Well, maybe so. Well, here we've stepped up a rung on this ladder of abstraction. Well, now we're looking at an aerial photograph of the community where we are. And just so that we kind of can get oriented here is our school. And we're going to try to find the best way to get to here. All right, so aerial photograph still has a lot of information that's not relevant to our discussion here about how to get to school. So let's abstract this a little further. Well, we can overlay this with lines of longitude and latitude, so at least we can locate where on the planet this is, but I don't know, did that reduce the amount of information or did that increase it? In some ways it increased it, and it's not getting me to what I want to know. So can we abstract this in a different way? Now this looks better because we've reduced the amount of irrelevant information and getting down to maybe what's important to us. So now the question is, how do we get to school? And well, what can we do to analyze that? All right, well, let's take a look at this. Okay, let's say maybe that we live here. Well, we leave the house, go down the street, and when we get to the corner, we turn till we get over here to this main street, turn south, turn into school, into the parking lot, and then turn into our parking place. That's the path that we're going to take to get from point A, over here where we live, to point B at the school. All right, that's some relevant information. What if we make this a little bit more abstract? All right, now we just have the arrows that we just drew. And this is sort of interesting because, okay, well, how's that interesting? What does that do for us? Well, we'll start to talk about vectors later in school. Now, if we take these arrows and now we've got some north-south direction that we moved. Well, we went east, but then also we turned back west, and maybe we can evaluate that in some way. What is it that we really wanted to know there? Okay, well, I don't know. Let's see. Let's put another arrow on here that might be something interesting to us. Maybe what we really wanted to know was what this displacement was, how far it was from home to school, and how long it took to get there. Now we're really starting to turn into something that really is pretty abstract. You know, getting a little bit ahead. We'll talk about these more later, but we've got some vectors here. Well, okay. Well, what if we called this net distance here A, and this B, and this C? Well, then all of a sudden maybe I've got some kids going, hey, I know this. C squared equals A squared plus B squared. So the distance C might equal the square root of A squared plus B squared. And all of a sudden we're at this mathematical abstraction. We have, you know, some formulas here. We have a function that informs us in some way about the question that we had. Isn't that really cool? What else could we look at here? Well, all right. Let's look at this some other way too. Can we graph some of this information? If we make a graph here, well, what were the things that really interested us here as we look at this? Well, we wanted to know how long it took to get to school, and we wanted to know how far we have to go, and so how fast do we have to drive to get there? Well, that's kind of interesting because if we follow the red path here, we get one set of answers. All right, let's kind of look at that. If you follow that red path, originally we had to go a large distance over some amount of time. So maybe we had to drive pretty fast. But maybe the question then becomes, well, what was the velocity if we look at the displacement over time? Well, we're going to talk about that more later. but the displacement was much less distance, but in the same amount of time. And so now we've got some way to graphically analyze this real world situation that, if you remember, we started all the way back there with the street. All right. So now let's look at these things. We narrowed it down to the information that was truly